One.
What's good, y'all? This is the introduction to 10.2, Introduction to Conics. And once we get into conics, we're going to learn about parabolas. So first of all, what is a conic? A conic is the type of shape, or the conic section is the type of shape you're going to get depending on how you intersect a plane with a double napped cone. And when I say double napped cone, I'm meaning like, are these cones right here that are placed nose to nose. So when they like meet right here, they're like nose to nose. So there are 4 specific types of figures that you're gonna get when you intersect a plane with a cone. So first is a circle, and you can see that here, when you intersect the plane and it's parallel to the end of the cone here, you're gonna get a circular figure. The second is when you tilt that plane slightly, but it still goes completely through one of the cones, and what you're gonna get is an ellipse. The third shape that you're gonna get is a parabola, and this occurs when you take the plane and you kind of like tilt it, and it only goes through part of the cone, but it doesn't slice it completely. And you see we're just going through like one part right here, whereas the ellipse went through, doesn't go through. You're just slicing over a piece basically. The shape that results from this is a parabola. The last one you're gonna get when you intersect a plane and it's perpendicular to the end of the cone, then you're gonna get a hyperbola. But we're gonna specifically focus on parabolas.
One.
So we're familiar with the general equation for parabolas. That is ax squared plus bx plus c. But we're going to go into the definition of parabolas. By definition, a parabola is the set of all points x, y in a plane that are equidistant from a fixed line called a directrix, and a fixed point not on the directrix called a focus. So we got the 2 new terms. We have 2 new terms here: a directrix and a focus, as you see here. And I drew up a graph, so it's best to show an example of it. Every single point of this parabola is equidistant from this point, which is the focus, and this line, which is directrix. So you can pick any point in this parabola, and it'll be the same distance from both the directrix and the focus. So for example, take point P. This distance here, if you take it straight down to the line, it's going to be the same distance as if we were going to go from here to the focus. The same exact value. If we took one that's like even closer, say we take it right here, the distance from this point to the directrix, we call x, and it's going to be the same distance as to the focus. They're the exact same. So no matter what you pick in a parabola, it'll always be the same distance from the focus and the directrix. So now that we learned those 2 new terms, we're gonna take a look at the equation of a parabola. This is the standard equations right here. So the standard equation for a parabola is x minus h, the quantity squared, equals 4p times y minus k. We also have it in the flip form, whereas the white part is squared, so minus k squared equals 4p times x minus h. So that's going to be the sideways parabola. The parabolas that are most common and that we're familiar with are going to be a U-shaped or upside down U-shaped, such as this one right here. However, we also have the sideways parabola, as you can see. It will look just like this. So this will be the sideways parabola. And we got some new variables here. So we got an h, a p, a k. The h comma k is the vertex, and that's going to be your vertex of the parabola. P is the distance of the focus from the vertex, from the parabola. So we have, from the previous, we had the focus was right here. So right here, P would be this distance right here between the focus and the vertex. So depending on what type of parabola you have, it'll either be added to the y coordinate, if it's a right side up parabola, or to the x coordinate, if it's a sideways parabola. And just know that the vertex is always going to be the midpoint between the focus, the focus and the directions.
So the first example I did for 10.2 was find the standard equation of the parabola vertex at the origin, focus 2, 0. So the first thing you should do is sketch the given information, because it helps you find the parabola. So my focus is at 2, 0, so I'm going to put my focus right there. So the focus is always on the inside of the curve, so that tells me that my parabola is going to open to the right, and it's going to tell me that my directrix is going to be over here actually. So it's going to be at x is equal to a -2, because the distance from the focus to the vertex is the same as the distance from the vertex to the directrix. Alright, so this equation is going to be, so the equation is going to be 4px equals y squared. My p value is going to be 2, because it's the distance from the vertex to the focus, so my equation is going to become 4 times 2x, and then y squared, so I'm going to get 8x is y squared. And there's my standard equation. So the next problem is going to be find the standard form of the equation of the parabola vertex 1, 2, directrix of y equals -1. So to begin with, I'm going to sketch the graph again. So here's my little quadrant system. My vertex is at 12, so there's a 1. My directrix is y is equal to -1. Alright, so there's my directrix, which means that my parabola goes up. So remember, the distance from the vertex to the directrix is p. So this distance is p. So I have 1, 2, 3. So p is going to equal 3, and so it's not okay to count spaces. So my parabola goes up because the directrix is always gonna go outside the curve, and the focus is always inside the curve. Then that's going to be the shape of my parabola. So my generic equation is going to be 4py is equal to x squared, and I know I'm going to translate it, so that's going to be 4py minus k is x minus h quantity squared. Now you can just substitute it in all the numbers that I know. So I have a 4, so we determined that p was 3y minus 2 is equal to x minus 1 quantity squared. If you simplify, you get 12 times y minus 2 is x minus 1 quantity squared, and that's the equation. So the first equation we have is find the standard form of the equation of a parabola vertex 2, 1, focus 2, 4. So the first thing we do is sketch a graph, so we know where the parabola is going. So my vertex is at 21, so it's right there. So so my focus is at 2, 4. So here's 2, 1, 2, 3, 4. So my focus is up here. Remember that the inside curve, so that tells me that the inside curve tells me that my parabola points up, and it's going to have the generic equation 4py is equal to x squared. And then if I wanted to add my translations, it would be for p times y minus k is equal to x minus h squared. Alright, so I know the coordinates of the vertex, so I know my h and the k. The only thing I have left to find is p. So remember that p is the distance from the focus to the vertex, and if I subtract my p, it's going to equal 4 minus 1 equals 3, so my p is 3. So if I write my equation now, I'm going to have 4 times 3 y minus 1 is equal to x minus 2 quantity squared. Simplify that just a bit. So 12 minus 1 is x minus 2 quantity squared, and that's the equation in standard form. Okay, so for our last two problems, I'm going to differentiate between a parabola, an ellipse, a circle, or a hyperbole. And there's two problems here, and I'm going to tell you what they are and why they are what they are. So for the first one, I'm noticing that I have 6y squared and a positive 6x squared. So a few important details. First of all, both y and x are squared, so it's not going to be a parabola for sure. They have the same coefficients and they're both positive. One that's true, when it has one of these characteristics, I know that it is going to be a circle when this is true, because both x and y are squared. So for the next problem, there are no longer the same coefficients. Both x is going to be squared if I were to FOIL, and y is squaring if I'm going to FOIL, but there are different coefficients, and they're both positive. It's important to note that they're still both positive with these characteristics when I know that this is going to be graphed as an ellipse, because they're both positive. So yeah.